As many of you know, my name is Pia Rodriguez, and I'm here with my colleagues, Dr. Shi Wang and Luke Bartlett, and we are all at Duke University. We are hosting this event with generous funding from the Chan-Zuckerberg Initiative in a partnership with Duke University. And this is the second of two of our events within the Duke-CZI Neurodegeneration Challenge Network that we're hosting. So today we are joined by Dr. Alberto Espay and Benjamin Stecher to discuss their book that they co-wrote called Brain Fables, The Hidden History of Neurodegenerative Diseases and a Blueprint to Conquer Them. This book, as you know, is incredible, and others have recognized it as such. It's been selected by the Association of American Publishers for the PROS Award, honoring the best scholarly work in neuroscience published in 2020. So we hope that today's discussion will give us an opportunity to learn a combined perspective from patients, clinicians, researchers from academia and industry present here today. And before we get started, we'd like a chance to introduce Dr. Alberto Espay and Ben a bit more. So next slide. Wonderful, thank you. So first, Dr. Alberto Espay is currently a professor and endowed chair of the Center for Parkinson's Disease at the University of Cincinnati. He's published hundreds of research articles and 8 books, including The Common Movement Disorder Pitfalls, which has received high praise, and the BMA Medical Book Award in 2013. He's incredibly involved and a leader in this community. He's the current chair of the Task Force for Technology and secretary of the International Parkinson's and Movement Disorder Society, and many other groups. As many of you may know about this study, but with colleagues at the University of Cincinnati, he recently launched the very first biomarker study of aging called the Cincinnati Cohort Biomarker Program. Dr. Espay, if you'd like to jump in and say maybe a fun fact about yourself, something more human than all these amazing accomplishments, please feel free. Thank you for being here.
Thank you so much, Pia. This is such a wonderful place for me to be. I think this is a bit of a coming full circle for me because my initial calling in life was literature. I love poetry and I wrote short stories when I was a child. And I thought I was going to become a journalist, but my parents felt differently about me. They felt that journalism wasn't going to be quite as important and convinced me to follow on the path of medicine. So after writing a few books for really medical education, this is the first book that truly allows me to perhaps think about my roots. So that's my fun fact. I would have been a journalist, and perhaps this is a way to live that dream.
Wow, amazing. That is really, really cool to know. And I think the book is a great transition and middle ground between your two loves, neuroscience and journalism. Thank you so much.
Thank you.
Next, we have Dr. Espay's co-author on Brain Fables, Benjamin Stecher. Many of you may remember him. He was one of our keynote speakers from our Bench to Bedside speaker series last fall. So thank you so much, Ben, for sticking with us and coming back to share more of your expertise. So Ben studied philosophy and history at the University of Guelph, and he spent nearly a decade as an educational consultant in East Asia. This changed for Ben when he was diagnosed with Parkinson's disease when he was 29, but it only has fueled him to become a leader in Parkinson's disease patient advocacy and research since. He's devoted his life to this, founding the Tomorrow Edition, where he shares many of his knowledge and insights from all of his travels around the world, just meeting and talking to clinicians and researchers and patients in the neurodegenerative disease community. And he's also patient advisor to several organizations, including Toronto Western Hospital Movement Disorder Clinic and the Cincinnati Cohort Biomarker Program. As you may remember, Dr. Espay is one of the leaders in that program. So welcome back, Ben. Thank you so much for joining us. And likewise for you, if you would like to jump in and add any color to this introduction, a fun fact, please feel free to do so. And thank you again for your time.
No, thank you for having me. And it's great to be back here at, well, virtually at Duke. I wish one day we could do this in person. Actually, growing up, funny enough, my favorite team was the Duke Blue Devils in college basketball. And I love the team from 2 years ago with Zion and RJ and a bunch of others on it. So I hope one day we can do this in person and I can get a chance to visit all those crazy Dukies.
Absolutely. We'll host you. We'll have you for sure. Great. Thank you both again. Thank you so much for virtually being here and joining us. So everyone, join me in a virtual round of applause to welcome both Ben and Dr. Espay. And thank you again to all of you for being here. So during this discussion, because it's what we want this to be a discussion with both Ben and Alberto, feel free to jot down any sort of questions, thoughts that pop into your mind. Throughout the event, we'll have a big group discussion where anyone is welcome to share thoughts or comments with Alberto and Ben. And we'll also break out into slightly smaller groups, maybe, so that we can have a more personalized discussion as well later on. So feel free to engage and comment and ask questions. Okay, thank you. Next slide, please. So we're very interested, as I'm sure you all are, in sort of the birth of Brain Fables and the story behind Brain Fables. So here, both Ben and Alberto commented a bit on how this all began. So the first point here, the first question we had, and they answered it a bit here, but we'd love to hear from you both. How did you two meet? What was that meeting like for the very first time?
Yeah, so the meeting, so I became at some point very skeptical of a lot of the things happening in the field, and I had developed a relationship with the team here in Toronto. And the team is led by Dr. Tony Lang, and Dr. Lang was Alberto's mentor, and Alberto did a lot of his training in Toronto. And Dr. Lang came to know my own skepticism of some of the things that were taken as truth to be in the field. And he realized at that point that I needed to reach out to Alberto, because Alberto also has a very skeptical mind and is constantly questioning the things that we think we know about these diseases. And it was at that point that and also up prior to that, I had been reading some articles of Alberto's, and there was one in particular that was written in the Journal of Parkinson's Disease where Alberto talked about his vision for the future of how we're going to actually treat these diseases. And that really inspired me. That confluence of factors kind of brought me to send him an email and ask if I could interview him for my website. And from there, it was kind of, I think we quickly realized that it was a sort of match made in heaven. And we started sharing ideas with each other. We started exchanging emails, and at some point along the way, Alberto started telling me about this book that he had been envisioning for a while, and he sent me the first schematics of it, and I fell in love once again right away. I knew this was something I wanted to be a part of, and from there on, we just, over the course of the next 6 or so months, this was in 2019, we, through a flurry of emails exchanged multiple times throughout every day, we put together this book.
Oh, amazing. Sounds like it was just meant to be. Dr. Espay, do you have any, your side of the story there?
Yeah, I was so happy when Ben reached out to me, because I realized that he was doing so from a very different vantage point than most people in the past reaching out to me, right? This set of ideas that we have been discussing were not just intellectual curiosities. Here was someone for whom the discussions we were having were vital to himself. And so this was not just another way to discuss. So no, I was very, very pleased and in fact delighted. I think I fell in love with Ben right away, as well as he knows, and it was very easy to get to a point where in fact we would be working so closely together. This was a labor of love in many ways, and as we'll talk in a moment, you'll see that there is the voice of a clinician, me, and the voice of a patient, Ben's, connecting these ideas and bringing the concepts down to an actual person. So probably the greatest gift of the book is that none of these ideas should by now then be metaphorical or in fact just conceptual frameworks, but of an applicability to us today. And it's a major shift, of course, of everything that most of us have ever heard, and that's why the title Brain Fables. They're beautiful stories, but we need to move away from the fables and into what truly happens at an individual level.
Absolutely, yeah, absolutely. Importance in actionable facts and truths and how individuals are really affected. Thank you. So does anyone in the audience have any sort of comments about anything that Ben or Dr. Espay just said, some of the things that resonated with them?
Well, we have our first question in the chat box, I think, from Kathy that I think is worth addressing.
Sure.
First, if you don't mind. So first, there's the whole discussion around alpha-synuclein, and it's something that popped up a number of times to me throughout my journey. I mean, early on, I talked to a lot of researchers who would tell me, the one, I won't say the name, but I'll quote one in particular who said, "Synuclein now, synuclein forever." And at first, it was actually very reassuring, and I'm sure this is the case for a lot of people who are early in this field, that the thought that it all boils down to one problem, one misfolded protein, is very attractive. And it's very alluring, and it's frankly very hopeful as well, because it seems like we have an identified target. We just need to solve this one problem, and we'll fix what's going wrong in all of these people. However, the more I understood, the more complexity I started to wrap my head around, the more I understood that that was probably wishful thinking, and that boiling all of this complexity down to this one problem might not be as easy as we think it is, or it masks some of the complexity that's literally hidden underneath in some cases. And to answer the second part of the question from Kathy, we would love to have Duke be maybe a site one day of the CCBP, or if there's any clinicians there or any people there who might want to have the Duke act as a kind of satellite branch of the CCBP, I think that's something we would love to explore, because as you said, we'd love to have patients from all over the place be able to take part in this kind of program. So if there's any opportunities for that, if there's any like interest from any of the people there, we're happy to explore that further. I don't know if Alberto wants to add anything on to any of those points.
You've said it very well, Ben. I grew up in an alpha-synuclein centered world, and I think all of us have to some extent from our different vantage points. Of course, the book goes into some detail about how fragile the foundations of that concept is. It's been made very beautiful, and what has created the major stumbling block against progress is the fact that what we have always believed about alpha-synuclein as the cause of the problem is such a compelling story, and we all humans like reductionism, like to bring order to the chaos of biology into one concept. And the simpler the concept, the more attracted we become to it. But unfortunately, in this case, the blind allegiance to that concept is preventing progress. I love to say that science is driven by constant change of ideas, that hypotheses are created to be falsified, but we neurologists don't like to falsify our hypotheses because they are so beautiful. They are just great ideas, and it is super hard to say that a experiment that failed, or the many back-to-back negative clinical trials that we've had, are an indictment on our ideas. Our ideas are perfect. It's those darn clinical trials imperfections that are getting in the way. And so with Ben, the book brings a human with what we have called Parkinson's disease. And I hope that toward the end, you come away with the idea that, boy, we've really gotten to know so much about Parkinson's disease, and yet know so little about anyone living with this condition. So we've created this amazing model of disease. It's incredible how beautiful it is, like how complex it is, and how biologically fictional it is.
Yeah, absolutely. That disconnect is a big gap for sure. And I guess that really connects us to the next slide, which is your main hope and goal in writing this book. I think you've touched a bit on these already, but if you could summarize it, I know it's tough, but what is the main takeaway you were hoping that readers would be left with when they read Brain Fables?
Well, in many ways, what you guys are doing right now, this discussion is a living enactment of what we wanted. We wanted more people to start questioning some of these beliefs, even to question the conclusions that we reached in the book as well. I mean, we are not infallible. There might be some things that we wrote in there that can and maybe should be questioned. But the underlying goal, I guess, was to get more people to ask questions that seem to have been overlooked in the process of this disease, or in the study of this disease. And there's one quote in particular from the book that Alberto was very pressing in making sure that we put in there. Another quote from another researcher who I won't name, but who I asked him in an interview that I did, is it the case that if a trial fails, is it the hypothesis that's failed, or is it the result of the trial itself that's failed? And time again, it seems to be that we lay the blame at the foot of the trial. That goes to show to me that this imperfect method that we have of testing these hypotheses has stood the test of time, even though that might not necessarily be the best way to go about studying these kinds of things and testing these therapies. But anyways, getting back to the point at hand, this is what we wanted. We wanted more people to discuss it. We wanted more people to question it. We wanted more people to have these kinds of conversations, and then ultimately to hopefully inspire people to take action, similar to what we've done in Cincinnati with the CCBP, and starting to build those new programs that will eventually lead to the therapies that I and so many other people around the world are working towards.
Yeah, I fully agree. This is exactly what we want the book to elicit. In a related idea, we love the concept of curing Parkinson's. Curing Parkinson's is a great slogan, but it can never happen because Parkinson's is a man-made construct that doesn't apply to people. It just is a big idea that will have no applicability if we continue building it to anyone that lives with it. But because it's a slogan that attracts funding and that slogan has worked really well, there is a lot of money to be invested or in a iterative fashion in the same types of concepts, right? There is one therapy that is shown to really conquer Parkinson's in mice. And why should we not think that the very next idea is to bring that therapy to humans with Parkinson's, right? That's what follows. And so that's what we've been doing. We've been trying these molecules in people who we define as Parkinson's, and we assume that the model in which the therapies were tested applied to them equally well. And of course, all these studies have failed. So we've created a library of great molecules that we think are futile when we apply them to populations. What we never did is to try to match them by mechanism of action to those that would in fact be specific to benefit, that they would have the biological vulnerability to benefit if only we had done the work of connecting them to the therapy through a bioassay, which is, by the way, what the Cincinnati Cohort Biomarker Program, CCBP, is intending to do, is filling that gap. But if you ask investigators, where we are, we're getting very close. If we keep on doing, we're going to get there. We're about to find our first cure for Parkinson's disease. And they say we're trying different strategies time and again. And it's not true. We're trying different molecules, but the same strategy. And it is the definition of insanity. So somebody put it in the chat, Robert, like the war on cancer. Absolutely. At some point, we need to move away from the idea that Parkinson's will be cured, that Alzheimer's will be cured. Cancer hasn't been cured and will never be cured, but look at the progress in different types of cancers in different individuals with a well-defined biological subset of cancer. Then we have an enemy that we can in fact understand and target. And so that is the main goal for Brain Fables. Relatedly, by the way, because we neurologists and neuroscientists are so sure of ourselves, are so comfortable with the idea that we own the truth. And really, it's so much easier to keep on going and saying, we're going to get there. We're one of these days, we're going to cure cancer, Parkinson's. Then change is unlikely to fully come from within us. It will come, if it's ever going to come, from outside pressure. It's going to be from people like you saying, come on, guys, you cannot keep on doing this stuff. Right? And by the way, one first step that is a very practical step is to stop participating in disease-modifying trials. And I know this sounds crazy because you are all hearing, we all need to participate in research. But research of symptomatic therapies for sure is important, but disease modification, the therapies that are supposed to slow down progression of people's disease, none of them will fail unless those therapies have a way to demonstrate that the individuals targeted would have what it takes for them to respond to that therapy. So if you ask the question, what is it in this trial for me? What is it about the specific treatment that you're using in this trial that would make me a great candidate for it? The response cannot be because you have Parkinson's disease or because you have Parkinson's at an early stage. That won't matter. You have to say, because you have a change in the calcium metabolism about which this therapy works. And here's the test that shows that you have this particular. But I want us to put a moratorium on this study, because as shown in the analysis of all the trials done in Alzheimer's, in fact, 40% of those in the active arm were harmed, were worse when compared to those in the placebo arm. So this is not a matter of just having more patients or even including targeting them a little earlier. In fact, of those studies now, by the way, the study was published, the paper, it's just in 2020. By then we had 35 negative trials. We now have 41. And of course, the most poignant aspect of the 41, all negative, is that the latest bunch of them are in people, most of them without symptoms. People who have the proteins that aggregate in the brains, so they are the perfect individuals because they don't yet have the disease as we define it, but have the proteins. And in fact, those trials have been stopped early because in interim analysis, it's been demonstrated that where the treated arm is heading is in the opposite direction to that predicted, even though the clearance of proteins is successful. So the drugs are doing exactly what the drugs were destined to do. It just so happened that the outcome of these trials is in the opposite direction to that predicted. But God forbid we're going to use that to change our ideas. So I hope that this is a call to action for you. And I hate to put pressure on anybody outside of us because it should be our responsibility. But I claim unfortunately, I have to say that I'm acting on this rather late. It's much more comfortable to keep on doing. And for all of us, it's been comfortable. It is uncomfortable to have this discussion within our circles, but I'm glad that you're open to this discussion. And I'm hopeful that you will take this as a sign that we need extra pressure, and the more external to us the pressure is, the better and more effective it will be overall to change direction.
Wow, well, with that call to action, I think that's the best transition to move on to our open discussion. And I think we have many points to start already. And I will hand it off to my colleague Shi to guide us through some questions. And Shi, there are a few questions on the chat already. Thank you.
Yeah. Okay. Yeah. Thank you. Thank you, Pierre. And yeah, and thank you, Ben and Dr. Espay, for sharing your stories and then perspectives with us. And my name is Shi Wang. I'm a postdoc researcher in Dr. Chala Irugru and Dr. Albert Spada's lab at Duke University. And I'm here to facilitate our Q&A session. And then so just as Pierre mentioned, Patrick has already asked a question in the chat. Patrick, would you like me to read out the question for you, or you would like to unmute yourself and ask the question?
So I'm a researcher in Alzheimer's disease, and particularly interested in trying to model sporadic AD. And I think there's a lot of similarities between sporadic AD and what we could probably call random or sporadic PD as well. Mm-hmm. And I absolutely agree with what Ben and Espay are saying about the fact that this is a very complex disease. I'm wondering, have either of you spoken to program officers at the NIH about trying to fund multivariate models to address this multifactorial nature of PD?
So I've pestered some on Twitter. Sometimes they respond, sometimes they don't. But we're still in the process of, I guess, trying to get this message across to some of the funders and some of the people who are responsible for organizing these studies. I know that some of the big organizations have started to look into this. There are some attempts being made to try to put together multivariant studies. But as Alberto, I think, is very keen to point out, we almost need to go in the opposite direction. Rather than starting with the drug, it's starting with the individuals that are going to be applied, that drug is going to be applied to, and figuring out what is wrong with each of these individuals, and then which drug can we match to their specific dysfunction. And yes, I agree, though, that it's probably in most cases going to be a basket of drugs that is the most effective. I doubt that.
Really?
I doubt that in my brain there's only one thing going wrong, and in the brains of most people, I think it's a confluence of different factors. It might be enough if we just deal with one of those factors. That might be enough to stop the whole process or to slow the whole process anyways. But my suspicion is that I'm probably, somebody like me is probably going to need 2-3 different drugs acting on different pathways to really stop or ultimately reverse the process. And that reversal of the process is something that might be of interest to a lot of the people here, because I know there's a lot of basic scientists and there's people wondering about what kind of work that they should try to go down. And that's something that I know Alberto loves to talk about as well, is this replenishing what's lost as well. And it's not a matter of just stopping the process. We also need to make up for the damage that's already been done. So that might take us down a whole other path. It might take a long time to explain. So I don't know if we want to go into it in too much depth, but yeah, those are my.
One other thing, at some point in my research looking at PD, which, by the way, I was diagnosed with PD a couple of years ago, which is one of the reasons I'm on this call now. But with sporadic AD, we do know about environmental risk factors, with age being the most critical one, but then, of course, Western diets, low physical activity, stress, etc., are contributing factors in AD. Are there any known non-genetic risk factors linked to PD that hold water?
Right. Patrick, let me take it from here. You raise very important points. You're obviously someone that thinks a model will eventually work to explain large number of people's. It may be explain some people, but
Right, just one phenotype.
well, what's that?
It'll explain one endophenotype. There's probably 30
Yeah.
or 40 different ways to get PD.
And I think that the key component to the discussion we're missing is the who to that particular what. So we have a lot of whats that are very compelling, very interesting, but we don't know who the whats apply to. The what who mismatch is what we have. In fact, we have a what that's very interesting, multifaceted, but one that we don't know who it applies to. So let me give you an example of GWAS, Genome-Wide Association Study, is a technique to, of course, look at genetic polymorphisms that we think are associated with the risk of sporadic Parkinson's disease. And there have been several over the years. The latest GWAS was published in 2020. And it was a study, or actually, I think it's 2020. And it was a study on 35,000 people with Parkinson's disease to look at what part of the genome was associated. And here's the conclusion of that paper. And I'm gonna sort of, I cannot read it verbatim because it's not in front of me, but I'm gonna tell you what the results of this multi-million-dollar investment likely because it's not exactly worse, and you are going to tell me who it applies to. Out of these 35,000 patients, the investigators found that there were 90 genetic loci that collectively accounted for 32% of the variability to explain Parkinson's.
That's 32%, that's it?
That's it. So we are left to believe then what? That so if you do the math, 35,000 individuals give you 90 genetic loci to explain 32% of the variability. Does it mean that then we need what? Is it 800,000 patients to explain something along the lines of say 75% of the variability?
Right.
And let's say that we get there. What does it even mean to a person? What would that mean to Ben? How do I explain that to Ben to try to make sure that he knows that we're doing research to advance treatments for patients with Parkinson's? How does that, how could you envision that somehow I'm going to manipulate 90 different genetic polymorphisms in a way that would be important for Ben so that Ben would benefit? Can you imagine that? So that model research based on the idea of a model of Parkinson's disease. We think that we already know what Parkinson's is. We are so convinced we know what Parkinson's is that the biomarker discovery studies are based on the idea that the truth is known. That's called Parkinson's disease. And that's defined by us clinicians when we say you, and you have Parkinson's. Trust me, you have it because I'm an expert. So you come into this bucket and then you, and you don't. You don't have Parkinson's, we're going to call you controls. That's the independent variable of all the studies, meaning that that's the one that we are going to anchor all the analyses on. So now we measure everything we can, and we are going to apply statistical methods to define the extent to which certain things correlate with one group that do not with the other group. And in the process, we call them biomarkers of Parkinson's disease. As you can imagine, and as the book goes into some detail into trying to use the baseline data, in fact, if you repeat the same analysis in two different cohorts, you get different results. And the results that you're getting are not results that you can put to practice in anyone. So I think we're missing the who in this process. And essentially what is happening is that we are lagging behind other fields of medicine that long adopted precision medicine principles. And we are really insistent that technologies are there to kind of continue to validate that which we already believed, as opposed to being used to question everything we believe. And unfortunately, the word belief itself is something that is handed very commonly at meetings. Our meetings are all filled with debates and things, and people are supposed to talk about what they believe and what they don't believe. And really, science should be all about evidence for, evidence against, and the word belief should not be part of the discussion. Belief is for other fields, but certainly science hasn't benefited, at least the science done for Parkinson's, Alzheimer's, and other neurodegenerative diseases has not benefited from our belief, especially because belief is no match for, or I guess evidence is no match for belief. Belief is too powerful.
Wow. Thank you, Dr. Espay. Actually, I'm a researcher myself, and I completely agree with you. Sometimes as a researcher, we don't want to say our hypothesis is wrong, and then it's very easily to be biased, even in your own study. So it's I think these are very good advice, even for new generation of researchers. And I see in the chat, Alice has another question. And Alice, would you like to unmute yourself and ask the question?
Sure, I can. So I'm Alice. I'm also a researcher, and I'm well, not quite. I don't know if I'm qualified as a researcher. I'm a PhD student, and in psychiatry. So specifically, my research is looking at mood disorders and biomarkers. And so one thing that I really enjoyed about your book is how I could see a lot of the lagging parts or the flaws in Parkinson's disease applies to a lot of other fields as well, or topics. So for example, in psychiatry, I think overall. So that was quite interesting. And my question here is a little bit based on what you were saying earlier, how, there's this clear, something clearly is not working by picking a single gene, a single target, or whatever it is. Yet it persists over and over to this day, is what it seems. So do you think, as you were mentioning, in other medicines, like they have progressed a lot more further? Do you think there's something inherently, something different about neurodegenerative diseases or psychiatric diseases that is really putting us behind?
Great question, Alice. Yes, the main difference that's putting us behind is what we consider the anchor for research. The anchor for research is clinical criteria for neurology and psychiatry. We've created these entities because we have put together a variety of different symptoms. We think they kind of cluster together, which of course they do. And by clustering together, we figure they are a disease, right? Mm-hmm. So it's a definition of disease that we ceased to question. We are now trying to figure out how is it that this disease exists in biology, and are asking questions of biology to ensure that the concept we created is further validated and now has a biological basis to it. It isn't happening. It isn't happening. It won't happen. So the reason neurology and psychiatry are so far behind is because we insist that when we call someone bipolar, schizophrenia, Alzheimer's, depression, anxiety, post-traumatic stress disorder, you name it, that is the truth. That one day we'll figure out what's behind that. But the truth is what we already have established. That's the main problem with our field. Now, in other fields of medicine, that never is the truth. So if I were to be an oncology-minded neurologist of the future, I would say to somebody like Ben, coming to my clinic, I would say, well, Ben, you have something that's, I have no idea what it means. I would have to do this and this and this and that. All of these tests in blood, maybe some in urine, perhaps some in spinal fluid, perhaps an imaging study. And then I'll know what disease you have, and then I'll know how to treat you. Meanwhile, I have some levodopa that might make you feel better. That's how other fields of medicine have approached, right? But the way we're working is as if the oncologist of the present would say, wow, you have a lump in your breast, based on the temperature of the skin and the nodularity that I can palpate clearly, you have breast cancer. Here's your prescription. We're going to take that breast. It's going to radical mastectomy is the only treatment that any sensible doctor would actually do. So we are practicing medicine as if we were oncology in the 1970s.
Mm-hmm.
The field of oncology for breast cancer, as noted in the book, needed only one negative trial to disprove the hypothesis that breast cancer was one disease of the breast. Only one. It was a terrible study because everybody, right, was of course saying the truth is that radical mastectomy is the only treatment that any sensible doctor could ever consider for breast cancer. And it didn't pan out that way. There were no differences between the groups. So I joke, of course, that if we neurologists had done the analysis of that particular 1981 pivotal trial published in New England Journal of Medicine, we would have said, well, the study is negative, of course, because the radical arm was too conservative, the lumpectomy arm was just too radical, and the patient population was too advanced. We need to do another study with a more radical arm, a lumpectomy arm that's much more conservative, and patients that are not that advanced. Ideally, patients that have not yet had cancer, because that's how we justify the failures in our field. We're saying the main, most compelling argument for why trials in neurodegenerative diseases have failed is because patients have already symptoms, and once they have symptoms, it's too late. And of course, we're now reaping the devastating effects of explaining ourselves in that fashion, because the new batch of trials are all aiming at people that are normal, but they happen to have proteins that we have attributed toxicity to. And we don't want to abandon that idea because it's too compelling. And so the reason that we have to is because it's harmful. So the entire field of neurology and psychiatry, Alice, is in a state of development that's equivalent to the best of the 1960s and 70s that other fields of medicine got into. We need to move away from the idea that we clinicians are the arbiters of biology.
Yeah, and I'll only add that there's also a very human element on top of it all, in that when a patient goes to a doctor's office, it's nice, especially if they don't know what's wrong with them. It's very nice and it's very comforting to come away with a clear label and a clear disease that we can ascribe whatever symptoms they came into with. I remember when I was diagnosed, I was like, okay, I have this disease. There are people working on this specific disease, on the specific problem that I have. That's a very comforting thing in many ways. It would be much different if I walked away from that meeting and the doctor said, I have no idea what you have. You have something that some people call this, but in reality, no one knows what you have. Overcoming that is a challenge, I think, that needs to be addressed as well. And I don't have a perfect answer for that one. In the end, it comes down to kind of reading the individual and kind of making an assessment of what they can take and what they can't take at that given moment. But that element of it confuses and makes this whole situation a little more complex and a little bit more fuzzy, because we have all of these organizations all around the world that are dealing with Parkinson's disease, and we have labs that are devoted to Parkinson's disease. To suddenly come along and say this is a fable is in many ways, it's a difficult message to get across, and it's something that almost on a very human level, it's very tough for us to comprehend and to know how to navigate. But it's something that I think we need to be thinking about as well going forward. How do we, in some sense, rebrand or debrand these diseases?
Yeah, exactly. I can definitely see that as well.
And I would argue just quickly that we don't have to call them differently. I think that what we just need to do is assume that they are not the end, right? When we say anxiety, depression, Alzheimer's, Parkinson's, that's not the end, that's a beginning. It just puts us in the neighborhood, but it doesn't give us the address. And if without the address, we cannot really get to the core of the problem. To understand what to do about something, we need to know what that something is. And so far, the something that we're trying to fight against is a model. It's a model that's beautiful, like all man-made creatures. It's fantastic, right? And but we need to undo that. So the names are okay, but I want us to begin to think that Parkinson's isn't a disease, it's a construct, and it's the beginning of something that hopefully in the future will be like what we today say breast cancer. We know it's not a disease. it is many diseases, and in the future could very well be thought of as many diseases as people were living with breast cancer, because each of them will have a different combination of genetic and molecular abnormalities to them that would be addressable through a cocktail approach, as many already are. So that's hopefully a great model. And by the way, there is no reason to think that the brain is so special that it lives by a completely different set of rules that, all other organ systems, of lower systems, of course, they have their own lowish system of biological rules, but the brain obeys none of those. It has its very own.
Yeah, exactly. That was one of my thoughts as well. It's like, okay, we have cancer in different organs and different body parts, but look at them, there's still a lot more progress that was going on there. So why? But yeah, your comment definitely makes sense. Thank you.
Absolutely. So it's an important question.
Wow. Cool. This is I really like this discussion. Initially we were thinking about having a small group discussion, but when I look at the clock, like we've already have this long time, like a big group discussion that's already being very effective, and we learned so much from the discussions. And then now I'm going to, there are still some questions in the chat, and I've already copied and pasted these questions on my notebook. So I'm going to maybe pass them along to you, and to see if we have any time in the end, we can go back and discuss these questions. Now I'm gonna pass in our event to my colleague, Luke. And then so he is going to tell us some 4 important predictions that Dr. Espay and Ben made in their book, and then what's the new programs out there for Parkinson's disease research.
Thanks, Xi. Yeah, as Xi said, we've been really enjoying this group discussion, so I'm going to try to kind of fly through these so we can kind of get back to some final Q&A. But in Brain Fables, you guys made some really fabulous observations of the past and some hopes for the future. One of them being that that we don't look at this disease as one thing, but as many specific puzzles that should be tailored based on, as you said, evidence and not belief. And that can be accomplished, number 2, through these biomarker-based selection of patients for trials, and this matching of patients to therapies, as we've been talking about, and also just redesigning how we think about clinical trials in general. It's difficult because we want things to be standardized to a certain extent for generating new therapies, but at the same time, what's our goal? Is it to make things sure everything's as standardized as possible, or to produce effective therapies for our patients? So hopefully we can see some more flexibility in trials as we move forward. And I've been most excited about this point number 4 of looking at these larger phenotype agnostic kind of biomarker studies of aging, and using these just kind of unbiased approaches in research, because we do, as I'm a researcher as well, by the way, a PhD student here at Duke, and it's easy to get tied to a hypothesis, to say, oh well, the data I got from this experiment, I must have done something wrong. I must have not treated these brain slices like correctly, etc. When how many times do you do that before you say, oh well, maybe I should think of something new? And I think we're getting to that point, and it's people like in my generation of researchers coming up that I hope can really push this type of thinking through. I think it was Max Planck said, science proceeds one funeral at a time, and I'm hoping we can move things a little bit quicker than that. But unfortunately, it is sometimes the case that people who get to the top with these types of models slow down the progress on overturning them a bit. There is a lot of promising things going on, things that you guys are doing, Alberto and Ben. We're super thankful for all the ways that you're organizing to make these types of progress. And this book was really impactful for the way that I think about neurodegeneration. For specific organizations you list in the book, being the Link Clinical Trials programs, the Silverstein Foundation, the Aligning Science Across Parkinson's, and the Chan-Zuckerberg Initiative, which if anyone are unfamiliar with these groups, they're all doing really specific and interesting things to kind of change the way that we think and act on neurodegeneration. So you can look towards their websites for some more information there. So yeah, I would just like to get right back to some group discussion, questions and answers while we still have a little bit of time. I see some questions in the chat from Robert and Jesse. If either of you want to unmute to ask a question.
Boy, I could go on for an hour here with you guys. Really, I wish we went another hour. So my name is Bob Clark. I'm at RTI International. I've been an Alzheimer's researcher for 30 years. So when I started with Alison Goad, who discovered APP mutation in Alzheimer's, and who was a student of John Hardy, of course, with Selko, and did the amyloid cascade hypothesis. So I've been involved in Alzheimer's for a long time, but I've been mostly doing this a lot of systems biology. And I agree with your multiple phenotypes and multiple causes and things that should be broken down. I study late onset dementia as a phenotype more than looking at either the grave or the amyloid plaques and tangles, right, as the gold standard of what's causing Alzheimer's. But there is that thing with APP mutations and presenilin mutations that are affecting A beta 42 and causing the increase in that, and that does not jive with the protective effect with amyloid in those families. So that's one problem I had with what in your book. You didn't cover that, but
it's true. May I address this, because this is such an important book, and
there might be multiple Alzheimer's, but in that case, amyloid itself does not seem protective. So I just want to.
Right. So it is one of the most important arguments made against the idea that amyloid can be anything but toxic. And you're absolutely right. The APP mutation patients, the presenilin 1 and presenilin 2 mutation patients are evidence, we think, that the proteins aggregate in a toxic manner, that they overexpress proteins. But it actually, that argument holds if protein aggregation in sporadic patients happens by spontaneous generation. We know that those proteins come from somewhere. The overexpressed aggregates in APP patients also don't happen by spontaneous aggregation. They are happening because the normal proteins are inherently unstable and they aggregate therefore. Now, so proteins, here's a certainty in biology. Proteins can function in their normal state. Their normal state is soluble. So amyloid beta 42 is a soluble oligomeric peptide. The minute that it doesn't have that configuration, it ceases to work. That's a certainty, right? It doesn't work. What is the uncertainty? The uncertainty is that as it then aggregates into fibrils and form the plaques that we've come to realize are the pathognomonic sign of Alzheimer's, they acquire toxicity. That's uncertain.
That's uncertain. I agree.
Right. So let me start by saying that it is remarkable that we have assumed the uncertainty as the workhorse for all of our studies and completely neglected the certainty, right? So in APP patients, it's now been demonstrated that one of the earliest changes is that this soluble fraction of amyloid beta 42 begins to decline as early as 25 years before the onset of symptoms. Now, admittedly, so does there is an increase in the aggregated fraction. And so the question is, which one is it that creates the toxicity? Is it that the protein as it aggregates, or the normal protein as it becomes depleted in the process of aggregation. So you have normal protein in one end, abnormal protein. The normal protein turns into abnormal protein, and in the process of doing so, it loses function. So one pathogenic mechanism we have here that is a certainty is that the function goes away for the normal protein. The question is whether what is happening in this end is actually toxic. That's uncertain, but that's the assumption. So what evidence is there that this isn't toxic? A lot of evidence, a lot. So let me start by saying that by the age of 85, 65% of us will be amyloid positive. It's actually one of the in the last few chapters I thought you probably read that part.
And that's very well known in the field, and everybody, all the researchers know this.
Well, but the
and
funny
they still
thing
try to beat their heads against alpha-beta, at least in the clinical trials, right?
Well, but it's interesting that we all know this, but it's still that's the target for therapy. Now, let me tell you what it's not
because
in the book.
It's the target. There's no other targets right now that people are really, because the GWAS and all the other things, there's not really great targets. I mean, there are other genes that are such with GWAS, they're not really good. Yeah.
So the target is the one that I think we've not used, which is the idea of supporting the levels of soluble peptides, right? We're trying to deplete the aggregated, but how about supporting the peptides? So there will be a paper, Robert, that will be published in an open access journal. This is the open access branch of Lancet. It was rejected by 5 different high-level journals. One of the reviewers in one of the last iterations of review said something, wrote something there that I will have to frame at some point.
I can imagine.
He or she said, based on the data these authors had, which actually was all from ADNI, the analysis certainly is consistent and appropriate, but the results are incompatible with the evidence. Therefore, this paper cannot stand. So in other words, on the merits of the data for that paper, it was okay. There were no methodological issues, no major ones, but the results were incompatible. Let me tell you what the results were of that paper. So what we did is we studied patients, well, we actually studied all individuals with amyloid in the ADNI, which is the Alzheimer's Disease Neuroimaging Initiative. Of course, 1,800 papers have already come out of that. So it's, it's not, I hope not another ADNI paper. The question we ask is whether we could explain the paradox of having so many amyloid positive individuals with normal cognition by virtue of the levels of soluble above a threshold for compensation. So we ask the question, is normal cognition depending on the preservation of soluble levels in people who already have brain amyloidosis consistent with the Alzheimer's disease continuum? So what we did then is just only collected, those were 600 individuals in the ADNI cohort that are amyloid positive. And we divided them into tertiles of amyloid. The highest, of course, tertile, the greater the amyloid burden. And consistently across each tertile, so in other words, it doesn't matter how high the amyloid load becomes, what differentiates normal cognitive individuals from dementia is high soluble A-beta 42. In fact, what distinguishes normal cognition from mild cognitive impairment, statistically highly significant, still a p less than 0.001, so it's really robust, is also that those who have normal cognition have a higher soluble fraction of A-beta 42, the normal fraction, compared to those in mild cognitive impairment. So the normal cognition, mild cognitive impairment, dementia relationship was preserved throughout. So it was very clearly, no matter how many different adjustments you made, no matter how different ways of looking at the data, the answer is definitely that what really explains us staying cognitively normal is that those that are able to keep the levels above 800 picograms per ml are going to remain cognitively normal, regardless of what is triggering, of course, the phase transformation of these proteins from soluble to insoluble, from peptides, normal peptides to plaques. So I hope that this will be much more robust evidence in favor of the idea that we probably need to start paying more attention to the certainty in biology, which is the proteins function when they're normal, as opposed to the uncertainty that proteins become toxic. In Parkinson's, we've gone so far as to say that proteins acquire virus-like characters to them, right?
Yeah.
And it's very unfortunate. I think proteins do not behave like viruses. Proteins continue to behave like proteins throughout the process, and they go from soluble to insoluble. And the insoluble configuration, biophysically speaking, is a cross-beta sheet that is so stable as to be very difficult for it to be toxic.
Yeah, very interesting. Yeah, and just one quick point. I don't think, at least in the Alzheimer's field, and the researchers, nobody's wedded to it. I don't think. Maybe in the Parkinson's are more wedded to alpha-synuclein, but in the Alzheimer's field, and I'm on multiple review boards, multiple both at NIH and on many publications, and I get so much more ideas outside. It's probably 10 to 1 outside the amyloid question. So amyloid is just kind of out there. Everybody kind of acknowledges it, but all the ideas are coming elsewhere. But I do like that idea that we need to move away from the gold standard of Alzheimer's and Parkinson's as being clinical pathological at autopsy defined Alzheimer's, because that is clearly messing with all the studies. And that's what I really loved about your book there, that aspect that we need to move away from it. We still need to find something that's, I'm a geneticist, we need to find something that's a very strong phenotype, right? Because if you have, to get good genetics, you need a good phenotype to follow. And whether that's a biomarker that you find or whatnot, that's going to be paramount, I think.
Yeah.
But yeah, I love the fact of moving away from this gold standard of Alzheimer's disease, because as you said, you can have plaques and tangles and whatnot and just be perfectly normal aged person. Yeah.
Most often that's the case.
Right.
Most of us will be normal with amyloid, than the fewer, relatively speaking, of us that will have amyloid and have. So clearly, having amyloid in the brain is a bad thing. To have it, it implies something the brain is fighting against. What has been the problem is to assume that is the something the brain is fighting against. No, that's just a sign the brain is fighting against something. So
totally agree. Yeah, so I really hate to bring us to a close, but I just want to be respectful of everybody's time. Every time we do one of these events, it seems like we are just getting rolling when the event comes to a close. And so I just want to encourage everyone here to stay connected. We have a little bit of a Slack group that has been a good way for us to continue these discussions. And so I'll be sending an email very shortly to invite everyone to join that. And
also, Luke, sorry to interrupt, but we dropped the link on the chat too. If you're just ready to keep the discussion going right now, I can drop it again one more time. And Slack is great. We can chat and continue the discussion, and also network and get to know each other better. Sorry, Luke, I'll let you keep going.
And on top of that, feel free to give out my email address and contact information if anybody wants to follow up as well.
Right. Yeah, we'll do that. We'll try to compile kind of a contacts and resources email to send to everyone. I know Ben is active on Twitter. I've been seeing your activity recently. I'm on Twitter as well, so maybe we can kind of get a little bit of a advocacy force kind of going around some of these ways to rethink neurodegeneration. Ben and Alberto, thank you so much for coming today. Everyone else who's here, I'm really thankful. I'm sorry that not everyone got a chance to speak up today, but we, like I said, have some opportunities to stay connected. So I want to thank everyone for coming today, and also thank the Chan Zuckerberg Initiative, who's given us the funding to organize this group and really got the ball rolling on this on our side here at Duke. So with that, thanks to everyone. I hope you guys have a great day, and I hope this make some impacts rolling forward.
Thank you,
you,
everyone. Thank you so much. Thank you, Dr.
Thank you.
Espay and Ben. Always a
Thank you very
joy.
much.
And yeah, feel
Thank
free
you,
to chat
everyone.
on Slack and keep the discussion going.
Absolutely.
Thank
Take
you
care,
so
everyone.
much.
Thank you.
Take care.
Bye-bye.
Thank you.
Bye.
Bye.